The rover project Mars 2020 is in full swing at NASA, and the agency has chosen to base the new rover on the Curiosity design, which has been very successful. That means that the rover needs to slow down in the Martian atmosphere before activating its rocket-based landing system. NASA has just completed the first real-world test of the supersonic parachute that will help the rover do that. When rover 2020 enters the atmosphere of Mars, it will move to more than 12,000 mph at 5.4 km per second, and weigh about 2,000 pounds as a Curiosity. It takes a big parachute to slow down something like that, and the problem is much more complex on Mars. The atmosphere of the Earth is much denser than Mars, so the parachute must be extra large to produce enough resistance. The lower atmospheric pressure also changes the way the parachutes deploy, and that was the focus of the first test. Earth is not Mars, but there are still ways to test parts of the 2020 mission in the real world. Convoy behavior can be tested at high altitudes where the pressure is lower. These tests are underway in a program known as the Aspire Advanced Supersonic Parachute Inflation Research Experiment. In the first test just completed, a small Black Brant 9 rocket was launched from the Wallops Flight Facility at NASA's Goddard Space Flight Center in Virginia. The rocket reached Mach 3 while ascending to an altitude of approximately 31 miles 50 kilometers, where the first stage fell. The only payload for this launch was the parachute, which was activated when the second stage of the rocket began to submerge in the atmosphere. The mechanism was activated when it reached an altitude of 26 miles. The atmospheric density is similar to that of Mars, so it is a better test of the supersonic parachute. The 100-pound parachute fired from the rocket at almost 100 miles per hour. The rocket was still moving at 1.8 times the speed of sound, around 1,300 mph, while the parachute fully deployed, generating more than 35,000 pounds of drag force. A high-speed camera filmed everything at 1,000 frames per second. You can see that the footage slowed down at the end. The rocket was spilled in the Atlantic Ocean about 35 minutes after the launch, where NASA recovered it. NASA engineers will review the sequence of Aspire images frame by frame to study how the parachute behaved during deployment. This design is similar to the parachute used to land Curiosity in 2012, but NASA plans to develop an even stronger version of this parachute. That eventual system will become part of the final design of the 2020 mission.